Why does a heat pump look like it's doing something impossible, heating your house by pulling warmth out of freezing winter air? It feels like heat is moving backward, from cold to hot. So, what's the trick? Here's the short answer. A heat pump doesn't make heat the way a furnace does. It moves heat, like a conveyor belt or an elevator for thermal energy. And the electricity you pay for is the effort needed to lift that heat uphill, from a colder place to a warmer one. The first mind bender is this: even cold outdoor air still contains heat. Cold just means the air has less thermal energy compared to your living room, not zero. Unless you're at absolute zero, the molecules are still moving, still carrying energy. A heat pump's job is to grab some of that energy and deliver it indoors. To do that, it uses a loop of refrigerant and 4 key components. First is the evaporator coil, usually outside. The refrigerant enters this coil as a cold, low-pressure fluid. Because it's colder than the outdoor air, heat flows naturally from the air into the refrigerant. That added heat makes the refrigerant boil, evaporate, into a gas. Nothing magical here, heat is still flowing the normal direction, from warmer to cooler. Next comes the compressor, the muscle of the system. The compressor squeezes that refrigerant gas, raising its pressure. And when pressure goes up, temperature goes up too. Now the refrigerant is hot, hotter than the air inside your house. That sets up the third part, the condenser coil, usually indoors. The hot, high-pressure refrigerant passes through this coil and dumps heat into your home. As it loses heat, it condenses back into a liquid. Again, heat flows naturally from hot to cold, this time from refrigerant to your indoor air. Finally, the expansion valve drops the refrigerant's pressure suddenly. That pressure drop chills it back down, preparing it to absorb heat outside again. Then the cycle repeats, over and over, moving heat like a continuous loop. So where does the backward part come from? If you only look at the big picture, cold outdoors, warm indoors, it seems like heat is climbing the temperature hill. That's the opposite of what heat wants to do. The reason it can happen is the compressor adds work to the system. It's the same logic as pumping water uphill. Water naturally flows downhill, but if you spend energy on a pump, you can push it up to a higher level. A heat pump is basically a temperature pump. Now let's talk about the number that makes heat pumps famous, COP, the coefficient of performance. COP is simply heat delivered to your home divided by electricity used. If a heat pump uses 1 unit of electrical energy and delivers 3 units of heat energy into the house, its COP is 3. That sounds like cheating, like getting more energy out than you put in. But you're not creating energy from nothing. You're paying electricity to move heat that already exists outside. The delivered heat is the electricity you used plus the heat you collected from outdoors. That's why COP can be greater than 1. Here's a concrete example. Suppose your heat pump draws 1 kilowatt-hour of electricity. With a COP of 3, it can deliver about 3 kilowatt-hours of heat into your home. Roughly 1 of those kilowatt-hours came from the electricity, and about 2 came from outside air that the system harvested and carried indoors. But COP is not a fixed superpower. It changes, mostly with the temperature difference the pump has to overcome. The colder it gets outside, the harder the compressor must work to raise the refrigerant temperature high enough to heat your home. Bigger temperature lift usually means lower COP. That's also why you see defrost cycles in icy weather. Frost can insulate the outdoor coil and make heat transfer worse. And one more connection, a heat pump is basically an air conditioner with a reversing valve. In summer, it runs the cycle the other way, pulling heat from indoors and dumping it outside. Same physics, same loop, just flipping which coil is the evaporator and which is the condenser. So heat pumps don't move heat backward by breaking the rules. They follow the rules and spend a little work to push heat uphill. What should we break down next? Why some heat pumps struggle in extreme cold, or how refrigerants and pressure actually set the boiling point.